Good afternoon. Today I'm gonna explain about the NMOS versus PMOS and IDVD graph and IDVG graph. And next is the carrier transport in MOSFET and two operation mode about the MOSFET. Here, let's just start. First is the IDVD graph between in and MOS. So we can draw the IDVD graph like this. If we apply the gate bias, the IDVD graph will be drawn like this. So here, here, and like this. We can check the this part is the saturation part. Here. I didn't the graph well, so but please understand. And here is the saturation part. The red line is the saturation part, and the blue point is the edge of the saturation. So we can draw the edge of saturation graph like this. And we can check the edge of saturation increase like the scale graph. And next is the IDVD graph in PMOS. So we can the basically the PMOS is the work when we apply the minus gate bias. So we can draw the graph like this. So the graph will be drawn, and here is ID, and here is maybe minus VG. Because the PMOS work in minus gate voltage, so we can draw the graph like inverse MOS. So like this, this. And also here the red line is the saturation line, saturation situation, and blue point is the yes, edge of saturation. So in like NMOS, the NPMOS, the graph will be drawn like this. And next is the ID and VG graph. And look at this. And in NMOS, we can draw the ID and gate bias graph. So the graph will be the condition about the NMOS, the current will flow is if we gate bias over than threshold voltage, the current will be flowed. So we can draw the current is 0 and current will be flowed like linearly. So we can go graph like this. And this point is the maybe pretty threshold voltage. So the IDVG graph will be drawn like this. And next is the IDVG graph in PMOS. And like this, the PMOS IDVG graph will be drawn also like this. Here is ID and here is minus VG. So same about the same like MMOS. In PMOS, in PMOS is the threshold voltage like in if the threshold voltage in here before the gate bias bigger than threshold voltage, the current will be zero, and after the gate bias bigger than threshold voltage, the current will be flow like this. Okay, this is the is the ID and VD graph in NMOS and PMOS, and IDM IDVG graph in NMOS and PMOS. Okay, next is the carrier transport in MOSFET. We can draw the source channel drain diagram in NMOS. I will explain this carrier transports using NMOS. So we can draw the source channel drain diagram like this. Here is the conduction band, and this part is source, this part is drain, and this part is channel. So we can divide it like this. And as as we already know, if we apply the minus voltage, the energy band diagram will be offer, negative offer. And if we apply the plus voltage, the energy band diagram will be lower. So if we plus gate voltage in channel, the channel will be redrawn like this, like this. So, and this is the NMOS, so we can draw the Boltzmann-Taylor electron concentration like this. Sorry, like this. So the barrier in channel go down, so the excess carrier can move like this, but the conduction band in source and drain is now is symmetry. So this condition is, we can notice this condition is there is no BTS. So the barrier is lower, but there is no current flow. So when we apply the BTS drain and source voltage, I already mentioned if we apply the plus voltage, the band will be lower. So if I apply the plus voltage in drain, the graph will be drawn, will be drawn. Sorry, I will redraw again. The band diagram will be drawn like this. As we can see is here is source and drain, and here is channel. So I already mentioned I applied the plus voltage in drain, so the part of drain will be lower. So the carrier, the electron can move to here. So if the VDS is exit, if the VDS exit, the current can flow. And as you can see in this diagram, band diagram, the most band bending is occur in channel, in part of here. The channel, the bending and the band bending like this, but the source and drain part is not change. So we can I explain the carrier transport in MOSFET. And next is the operation mode about the MOSFET. First is the enhancement mode, and second is depletion mode. We can divide these two modes easily. So when the gate bias is zero, enhancement mode have no channel, and otherwise the depletion mode have already channel. So the graph about the graph in enhancement mode maybe drawn like this. Here is I and V, and in PMOS the graph will be drawn like this. As I already talked, in BGS, if the BGS is zero, there is no channel. So here point is the BGS, and here is the BGS. So we can check there is no channel in using the graph. Otherwise, the depletion mode graph will be drawn like this in MMOS. Here is SIVG, and in PMOS, the graph will be drawn like this. Here is I, and here is minus VG. So at first I was talking the in depletion mode, depletion mode has already made the channel. So this point is VGS. This is VGS. So we can check the difference between enhancement and depletion mode. Enhancement mode have no channel when the gate bias is zero, but depletion mode have channel when the gate bias is zero. This is the difference between enhancement mode and depletion mode. Thank you for watching this video.